What if everything we thought about light is wrong? What if the one true constant in our ever-changing universe isn't constant at all? Let me explain. One of the most important values in physics is the speed of light, approximately 299,792 kilometers per second. It's so important, in fact, that it's often represented by the letter c, as in the speed of causality. Alright, maybe not that c, but definitely this one. Albert Einstein built his entire theory of relativity around the idea that the speed of light never changes. This constancy allows us to calculate distances and times across the cosmos with an accuracy that has allowed us to discover and map the universe as we know it. But what if the speed of light isn't constant? What if it's changing over time? Now, before you click off this video and send an angry tweet about how my title is clickbait, stay with me. We won't know for sure until we test it, but some physicists think the speed of light might be slowing down. And while that sounds kind of crazy, it's not as far-fetched as it sounds. Here's why. For decades, the idea of a varying speed of light was considered a heretical idea outside the mainstream of physics. But now, several prominent researchers believe it could be possible. In 2021, physicist João Magueo and his colleagues proposed a model where the speed of light began at 299,792 kilometers per second after the Big Bang, but has been decreasing at a rate of 20 meters per second per billion years. That means the speed of light today is only 299,792 kilometers per second, a tiny reduction from what it was in the early universe. But by the end of the universe, it will have slowed to just 299,789 kilometers per second. You might think, okay, so what? A 3 kilometer per second difference is nothing compared to the immense speed of light. But this small change can have huge consequences. First, it would mean that many of our physical laws need to be rewritten. Take Newton's law of universal gravitation, which defines how gravity depends on mass and distance. It assumes that the speed of light is constant. If that isn't true, then the law of gravity needs to be modified. Same thing for Maxwell's equations, which define how electric and magnetic fields behave. They also assume a constant speed of light. So if the speed of light isn't constant, then Maxwell's equations need to be rewritten, too. But even more importantly, this would mean that time itself needs to be redefined. Remember that time is relative. It depends on your frame of reference. As Albert Einstein taught us, time passes slower for objects that are moving relative to you, because the speed of light is the ultimate speed limit in the universe. Anything that travels close to the speed of light will appear to move through time much more slowly than you. This is called time dilation. Astronauts on the International Space Station actually experience time slightly slower than you do, because they're moving pretty fast. They age slightly less than 1% slower than people on Earth. So if the speed of light is changing, then the way we measure time needs to change with it. Now, you might be wondering, how could the speed of light be changing when we've never observed it change? Well, that's a great question. Here's the thing. The speed of light hasn't necessarily changed over human history. There's no evidence that it sped up or slowed down since we started measuring it. But physicists who believe the speed of light might be changing argue that it could have changed over cosmic time, billions of years ago. So why would the speed of light slow down? What would cause such a change? Physicists don't know for sure, but one idea is that the vacuum of space is actually full of quantum field fluctuations that prevent light from traveling perfectly through space. These fluctuations could have an effect on the speed of light, and that effect could get worse over time. Another possibility is that the expansion of spacetime itself causes these fluctuations that slow light down. If the speed of light is truly changing over time, it means there is something else changing in the universe as well, possibly dark energy, which we know exists because of the accelerated expansion of the universe. The leading hypothesis is that dark energy is a cosmological constant. The issue is that the value of the cosmological constant doesn't match what we expect based on observations. Scientists refer to this as the worst prediction in the history of science. Another hint comes from the study of distant quasars. As their light travels billions of years through space, it could have lost some energy due to a slowing speed of light. Researchers have reported that the light from some quasars could be dimmed by as much as 20% if the speed of light is changing. I know what you're thinking. Wait, if the speed of light is slowing down, wouldn't that make distant objects appear more redshifted? Wouldn't we be able to see the dimming you just mentioned? It's a great question. The answer is yes, but it's complicated. Changing speed of light would certainly affect the way we see distant objects. but scientists haven't figured out exactly how yet. This is why the idea of a slowing speed of light is such a hot topic among physicists today. It's such a radical idea that it requires rethinking some of the most fundamental concepts in physics. But it's an idea worth exploring, because it could reveal new insights into the nature of light and the evolution of the universe. Take, for example, John Archibald Wheeler's participatory universe. This is the idea that observation plays a role in the collapse of the wave function and that reality is created through the interaction between observer and the observed. This may sound similar to the double-slit experiment where the act of observing the particles somehow affects their behavior. While Wheeler's ideas were highly influential, they remain controversial, with many physicists arguing against the notion that observation plays a unique role in quantum mechanics. However, if we find that the speed of light is changing, then it would provide some support for this idea, because it would mean that the relationship between space and time is not absolute but depends on the observer's frame of reference. Okay, let's go back to the video. In the end, there are more questions than answers when it comes to the speed of light. Is it constant or is it changing? Does time need to be redefined? What does it all mean? But one thing is for sure, the universe is still revealing its secrets and there's always more to discover. However, if it turns out that the speed of light really isn't constant, it would shake the foundations of modern physics and our understanding of the universe. It would force us to rewrite some of the most fundamental laws of nature and redefine concepts like space and time. And that's not all. It would also raise some deep philosophical questions. What does it mean for something to be constant if the speed of light isn't constant? Are constants really constant? Or are they just human constructs that depend on our frame of reference? Could there be other physical quantities that we think are constant but are actually changing? This idea challenges our intuition about the nature of reality and suggests that the universe is far more complex than we ever imagined. As Carl Sagan said, we only know a tiny fraction of what there is to know. So who knows what other surprises the universe has in store for us? Maybe the speed of light is changing. Maybe space and time aren't as real as we think they are. Maybe the universe is a cosmic illusion. But one thing we can be sure of is that the journey of discovery is never ending. There's always more to explore, more to understand, and more to wonder about. So keep asking questions, keep searching for answers, and above all, keep your mind open to the endless mysteries of the cosmos.